Today in this video we shall discuss the problems based on V belts. So here in the sketch we have shown this is a V belt, that is this is the groove, or pulley, and this is the belt, V belt, which is used to transmit the power. So we shall read the problem. A V belt drive, it is designed to connect two shafts 1000 mm apart. So here the two shafts, they are 1000 mm apart. The diameter of driving pulley is 400 mm and transmits 60 kilowatt at 900 rpm. So the diameter of driving pulley is 400 mm. That is the usually we consider smaller pulley as driving pulley. So here the diameter is 400 mm and transmits 60 kilowatt at 900 rpm. We shall write the data. So the center distance C is 1000 mm. The diameter of driving pulley we usually indicate by small d, 400 mm. Power transmitted is 60 kilowatt, and the speed, here for speed I'll give ns, that is cs is for smaller pulley, 900 rpm. The follower pulley rotates at 300 rpm. So this is larger pulley is 300 rpm. Angle of groove is 40 degree. So here they have given angle of groove is 40 degree. So that angle is nothing but if we extend this line like this. So if we extend the straight line of the belt, so this is the angle of groove. Here this is the angle of groove alpha. So alpha, we shall consider this as alpha 40 degree. And coefficient of friction between belt and pulley rim is 0.25. So coefficient of friction between belt and pulley rim is 0.25. Coefficient of friction mu is equal to 0.25. The area of belt section is 270 mm square. So area we shall consider A, 270 mm square. So this is, if we take the area of this hatched portion, that is the area of V belt section. So that is what they have given here, 270 mm square. And the permissible stress is 2 MPa. Sigma is equal to 2 MPa. Density of belt is 1000 mm. Density rho is equal to 1000 kg per meter cube. Calculate the number of belts required. So they are asking us to find the number of belts n or n dash, and the length of the belt. So length of the belt L. Also find the initial tension. In the belts. So initial tensions is T1, T2 and T0. T0 is the initial tension, and to find T0 we need T1 and T2. So n dash is number of belts. It is nothing but consider one pulley. Here we have shown only one belt. In some pulleys they will mount number of belts. Here it will be like this. So here again there will be one belt. Like this, on single pulley multiple V belts will be mounted. So here I have shown only single V belt, but usually there will be many number of belts. So before proceeding we shall take the velocity ratio. I is equal to, velocity ratio I is given by n larger pulley, ns by nl. So I is speed of smaller pulley by speed of larger pulley is equal to d by d. So ns by nl is equal to d by d. So this is diameter of larger pulley and this is the diameter of smaller pulley. So from this formula, the diameter of larger pulley we will get as 1200 mm. we shall find the velocity of driver, pi dn by 60. So the velocity which we will get as 18.85 meter per second. So this is the value of velocity we will get, 18.85 meter per second. Next we'll find the angle of contact for smaller pulley. So to find the angle of contact, we shall go to the first page number 289. Here on smaller pulley, the angle of contact. So we shall take this formula. Here they are given for open belt drive. So this is same for both open belt drive and V belt drive. So this formula is given by 14.1a equation, page number 289. Pi minus so angle of pulley on smaller pulley theta s is 2.34 radians. If you take this formula, you will get directly in radians. So in data handbook there is another formula. If you take that formula, you will get the angle in degrees. Next we have to find the apparent coefficient of friction. So here the coefficient of friction we need to consider for this side and this side also. But in case of flat belt drives, the contact between the belt and the pulley was only at one side here. So we used to take the coefficient of friction at one side. But in case of V belts, there is three sides contact with V belt to the pulleys. So here, and there are three sides contact. So we have to consider the apparent coefficient of friction. In data handbook there is a formula, mu1 is equal to mu divided by sine alpha by 2. So this is the formula for apparent coefficient of friction, page number 294, equation 14.12. We shall take this formula, mu divided by sine alpha by 2. So this alpha, it is nothing but the angle, groove angle. So here explained earlier, if we extend the straight line here, this angle is known as alpha. So this is equation 14.12, page number 294. So the coefficient of friction, apparent coefficient of friction, we shall find it. So the apparent coefficient of friction is 0.731. So we will call this as mu1. Next we shall go to find the value of number of belts. Here they are asking us to find the number of belts. So we shall take the formula from data handbook from page number 295. There is one formula here for power. For power there is a formula, n dash AV by 1000 into sigma d minus WV square by 10 power 60 into e power mu 1 theta minus 1 by e power mu 1 theta. So we shall take this formula and we will find the value of number of. I'll take the formula here. Power P is equal to n dash AV by 1000 So this formula is from equation 14.16a, page number 295. So here n dash, it is nothing but the number of belts. So power they are given in the question as 60 kilowatts. Area also they have given 270, into velocity is 18.85 divided by 1000. Sigma they are given as 2 MPa minus this W is nothing but rho G. So here already there is G. So if I write rho G here, G will cancel and I will remain with rho. Rho in question they have given as 1000 kg per meter cube, density of the belt. So I'll write 1000 into 18.85 square divided by 10 power 6 into e power mu theta. This is mu 1 theta. Mu 1 we have found out 0.731 into theta is 2.34 radians minus 1 divided by e power 0.731 into 2.34. So on simplifying this equation, I'll get the value of n dash as 8.75. So we shall approximate this to 9 belts. So there will be 9 individual belts on the single rim or pulley. So next we shall find the value of tensions. We shall consider the power T1 minus T2 into V by 1000. We shall take this formula. This is the basic formula for the power. We shall find the tensions T1 minus T2 into V is 18.85 by 1000. So by this formula I'll get the value of T1 minus T2 as 3183.02 Newton. So this is the form value which I'll get. Next we shall find the value of tensions. Now we have found out this difference in tension T1 and T2. We shall call this as equation 1. Now from data handbook we shall take the formula for belt tension considering the centrifugal tension TC. So for in here there is V belts, page number 294, equation 14.12. T1 minus TC divided by T2 minus TC is equal to e power mu 1 theta. Here before proceeding I need to find the value of TC here. 14.12, page number 294. So to find TC there is a formula. The formula is same for both flat belt drives and V belts. The value of TC which we are considering earlier, WBV square by 10 power 6, 14.3E, page number 291. We shall take the same formula. W again rho G and GG will cancel. I'll write 1000. Here the area B into T is area. They are given as 270 and V is 18.85 square divided by 10 power 6. So G is cancelled. You will write as 1. So the value of TC I'll get as 95.94 newtons. So now I'll substitute the value of Tc in this formula. T1 and T2 are still unknown. T1 minus 95.94 by T2 minus 95.94 is equal to e power mu1 theta. E power mu1 theta is 0.731 into 2.34. So by simplifying this equation, I'll get the value as T1 minus 5.54 T2 is equal to minus 5.54 into Tc. So Tc we already know the value. We'll substitute T1 minus 5.54 T2 is equal to minus 435.58. So now we shall call this as equation 2. Here we have equation 1 as T1 minus T2 is equal to some value, and here T1 minus 5.54 T2 is equal to another value. So by equating T1 and 2, that is, I'll send this value to the RHS and I'll substitute for T1 in this equation. So this equation, it becomes entirely in terms of T2, and I can find T2, and after finding T2 I can easily find the value of T1. So the values of T1 and T2. From equation 1 and 2, T1 and T2 is equal to, here I'm writing the final answers T1 and T2. I'm not simplifying, I'm not substituting this in this. If you have any doubts, you can call me. So here it's very easy. First what we have to do is, we have to send this 5.54 T2 to RHS. Then this equation, it becomes T1 is equal to something. So this value we have to substitute in this equation for T1. So this equation, it becomes entirely in terms of T2 and some numbers. So we can find the value of T2. Once we found out T2, we will substitute the value for T2 and we can find T1 from either from this equation or from this equation. So the final values T1 and T2 is 3980 newtons, and the value of T2 is 797 newtons. So this is the value which I'll get. So in question they have asked us to find the initial tension. So initial tension, this is the formula, T1 plus square root of T1 plus square root of T2 is equal to 2 into square root of T0. Equation 14.8, page number 291. So we have both the values T1 and T2. We'll substitute here and find the value of T0. So the value of T0 which we will get on simplifying this equation is 2084.76. 2084.76 newtons. So this is the value of T0 which we will get, 2084.76 newtons. So in question they had asked us to find the value of initial tension. Initial tension is this one, T0, and the number of belts. So we have found out. The procedure is almost similar when compared to open belts and V belts, but some values it will change.